Good day and welcome to our YouTube channel. So today we'll be doing Physical Sciences Paper 1 Grade 12 and we'll be doing two questions. The first one will be Newton's laws and the second one will be work, energy and power. Now I chose this particular question paper because it has this. So I'm just going to call this theta and this one I'm going to call alpha. I want to explain something which is actually where most learners or students make mistakes. Now, in an incline like this, we've got an object and that object has a force that is acting at an angle. So now we've got these two angles. We said this one will be theta and this one will be alpha. Now, let me just explain something about these before we do this question paper. Now, remember that we've got FG here, which is always acting towards the center of the earth. And then we obviously have to dissolve this to FG perpendicular, which is also a FG cos theta. We are using this angle for these ones, and then we also have FG parallel acting down the slope, which is also FG sine theta, since it's opposite to that theta and we've got our 90 degrees angle there. And then let's go to this one now. We've got a force that is acting there, which is going to be called F. And then we take that F, we dissolve it to these components. This will be Fx, which is the same as F cos alpha. And then we also have Fy, which will be the same as F sine theta. Now remember that when we are dealing with a question like this, we are not going to use this F because it doesn't act parallel to the motion of the object. So we'll need to make use of this Fx. And then also when we deal with things like, let's say for example, we're asked to calculate the kinetic or dynamic friction, which is the same as mu k multiplied by the normal force. One of the mistakes that students usually make is thinking that this normal force is the same as this Fg perpendicular, and they forget about this particular force there. Now, if we've got this Fy, and then we also have the normal force there, that will simply mean we've got two forces acting perpendicular and up the slope, and then we've got one that is acting downwards, which will be Fg perpendicular, and then these ones it's Fy and the normal force. Now, that will simply mean the normal force is equals to Fg perpendicular minus Fy. So you know that this is what you're supposed to substitute there. So if you just use Fg perpendicular, then you'll obviously be wrong if you just substitute this Fg cos theta. So that is one of the reasons why I actually chose this question paper, so that I'm able to explain this. Block P of mass 2 kg is connected to block Q of mass 3 kg by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. Block P is pulled by a constant force of 40 newtons at an angle of 25 degrees to the incline. Block P moves on a rough section, so they tell us that this is a rough section, so we definitely have friction. that is section AB of the incline, while block Q moves on a frictionless section BC. So BC we do not have friction, so when we deal with this block Q we won't be including friction as one of our forces acting parallel to the slope of the incline. See the diagram below. An average constant frictional force of 2.5 newtons acts on block P as it moves from A to B up the incline. So as it moves from A to B, it experiences 2.5 newtons there. Right. Now let's go and see what they are asking us now. State Newton's second law in words. Now, as a grade 12 learner, you know impulse. When we introduced you to impulse, we actually made some changes to our Newton's second law of motion, and we introduced you to this equation. And the definition of Newton's second law can change to be that for grade 12, where we say the net force acting on an object is equal to the rate of change of momentum. So that is the definition you can give and get your full marks. And then alternatively, you can use the one that you learned in grade 11, which is the one that says if a net force acts on an object, it will cause the object to accelerate in the direction of the net force, and the acceleration is directly proportional to the net force and inversely proportional to the mass, which is actually this use of F net. F net is equals to MA. So those are the two you can use and get your full marks. Now we move to question 2.2. They say to you, draw a labeled free body diagram for block P. And then here you always look at the number of marks. It will be the same as the number of forces that are acting on that particular block. So this one is out of 4 marks. We are expected to show 4 forces. So here we'll just be giving this object as a dot, and then we are showing the tension, we are showing the friction, and then we will be adding the normal force since it's on a surface. Then we'll just be including Fg, and then as you can see we've got 4 forces and 4 marks. And then we move on to the next question, which is 2.3, and 2.3 says to us, calculate the magnitude of the acceleration of block P while block P is moving on section AB. So when they say that, this actually says to you, do not forget to use this guy, the friction, because it's moving in AB, section AB. Now you can see the number of marks there is 8. So that actually says to you, you have to use simultaneous equations. Even though there is another simple way of doing it where you are treating these two objects as one, and you just include the Fk and one of those forces, which is the force applied up the slope. So I think I'll just be doing the one that is longer so that you get used to it. And then we start with the forces that are acting parallel to the motion. So on block P, tension is moving up the slope, and then we've got friction that is acting down the slope. We're obviously not going to include the normal force and the gravity because they are not acting parallel to the slope. There's gravity, so we'll only be using this one, the Fg parallel. So the normal force we excluded, and the Fg perpendicular because they're acting perpendicular to the slope and the angle is 90, so you know they do not actually contribute to the motion. So we'll be dealing with these three on this one: FK, FG parallel, and tension. And then we go to the 3 kg block. We'll be dealing with tension, Fx, which is the component that is acting parallel to the slope, and then we'll be having Fg parallel, which is the same as Fg sine theta. And remember, this sine theta that we'll be using is not the 25 degrees, but it's the 30 degrees. So even this one is Fg sine theta. So we've got three forces acting up the incline, on the 2 kg block, and the other 3 kg block. We've got 3. Then we go to this equation. F net is equals to ma. And then even on the other one, we'll be doing the same thing. F net is equals to ma. So now, on the 2 kg block, we know that the forces that are acting, okay, let's just choose a positive direction. I actually like choosing up the slope as positive and down the slope as positive. You know, the brain is actually used to working with up as positive, down as negative. So here we'll be having T minus Fk minus Fg parallel is equals to ma, which is 2a in this case. And then for the 3 kg block, we'll be having Fx minus tension minus Fg parallel is equals to 3a. And then here we have T minus, they gave us Fk, it's 2.5, minus, you know, the Fg parallel is Fg sine theta, and the Fg is actually mg, which is 2 times 9.8 for this one. So we just say 2 times 9.8 and then sine 30. All this is equals to 2a. And then for this one, the 3 kg block, we can say Fx is gonna be, remember, it's something like this. So this is F cos theta. So we've got 40, which were given the cos 25. Now this is the angle we're dealing with, not this one. This one will only be using for Fg parallel, minus T minus the Fg parallel is still mg sine 30, but now the m is 30. So we've got 3 times 9.8 sine 30 is equals to 3a. Remember, the a is the same since they are connected, the t is the same since they are connected. So that's why we're actually able to use the simultaneous equations. Now, to make things simple for us, we can just make t the subject of the formula, so that we've got two equations that are in terms of a. So t this side is gonna be equals to, let's just punch this on our calculator. So we say 2a plus, and then we punch the 2,5 plus, since they're both negative, 2 times 9.8, and then we put that sine 30 there, and then we get 12,3. and then we transpose that. It was negative this side, so when it goes to that side it becomes positive, so it's 12.3. Then we come to this one, it's 40 cos 25 minus t minus that, so we can just take the t to that side and take the 3a to the side, so the t becomes positive, and then we've got 40 cos 25, which is the same as 36.25. Now I do not like rounding off until I get to the final answer, so I can actually write this the way it is, or let me just punch the 40 cos 25 and the 3 times 9.8 sine 30. So it's 40 cos 25 minus 3 times 9.8 and then sine 30. So it gives us 21.55 minus 3a. This is our equation 2, this is our equation 1, and then from there we can just equate these two since they are both equal to t. So we've got 2a plus 12.3 is equals to 21.55 minus 3a. But obviously the answer is not as accurate as it should be because we rounded off this 21.5. This 12.3 just came as it is. So it's 5a equals, then we can just take this 12.3 to that side, and then for this one we just took the 3a to this side, hence we've got the 5a. So we've got 21.55 minus 12.3, and then we get 9.25, and then you divide both sides by 5 to get your a, and then your a is equals to 9.25 divided by 5, which gives you 1.85 meters per second squared up the incline, since the answer is positive. So that is how you do your 2.3. And now we go and do 2.4. If block P has now passed point B, how will its acceleration compare to that calculated in 2.3? Choose from greater than, smaller than, or equal to. So we want to know what will happen to this acceleration if now this block no longer has the friction. So now that means for this block we'll be having the tension and the FG parallel. We no longer have this other force, the FK. So obviously we know the acceleration is going to increase, so the acceleration is going to be greater than, since now we'll be experiencing a greater force upwards than this one that was opposing the motion. So the reason for the answer is because we've got no. Now we go to question 5. An object of mass 1.8 kg slides down a rough curved track and passes point A, which is 1.5 meters above the ground at a speed of 0.95 meters per second. Now the object reaches point B at the bottom of the track at a speed of 4 meters per second. So what they told us here is the mass of the object. Then they tell us that the slope is a rough curved track, and then they give us the height above the ground where it started and the velocity when it starts. They also give us the velocity where it's going to reach, which is point B. Now the first question says define the term conservative force. Now the conservative force is the opposite of non-conservative force. what is the conservative force? By definition, a conservative force is a force in which the work done is independent of the path taken. And then the non-conservative force is the force in which the work done by the force is dependent on the path taken. So examples of non-conservative force, that will be your applied force, that will be your friction, and then your conservative forces, the one that we usually get is the gravitational force. And then we go to 5.2, name the conservative force acting on the object. So it's obviously gonna be the gravitational force. Is mechanical energy conserved as the object slides from point A to B? Choose from yes or no, and then give a reason for the answer. So they told us that we've got a rough, curved track. So that means there's friction, and so mechanical energy is not going to be conserved. That is where now you make use of those equations, which are the work done by non-conservative force, the work energy theorem, and all those. So it's a no, because there's friction. And then 5.4, calculate the gravitational potential energy of the object when it was at point A. So at point A, we do have the mass, we do have the height, and we know that EP is equals to mgh. So it's going to be 1.8 multiplied by 9.8 multiplied by 1.5, and then you just punch that on your calculator, get the answer, and you move on to the next question. And the answer for this one is 26,46. And then obviously, since it's energy, it's measured in joules. And then they say, using the energy principles, calculate the work done by friction on the object as it slides from point A to point B. Now this is where it comes in handy to know the types of forces that are acting on the object. So since they just asked us to calculate EP, I'm thinking it's going to be wise for us to use the equation work done by the non-conservative force is equals to the change in EK plus the change in EP. Since we know that the change in EK is going to be, what's this? It's going to be half m into Vf squared minus Vi squared. And remember, they want the work done by friction, which is the work done by the non-conservative force, because that is the only non-conservative force that we've got. And then for the EP, we know that we'll be having here at the bottom, the EP, which will be EPF, is going to be 0. That is 0 meters above the ground. So the EPF is going to be 0. And then we already know the EPI, we just calculated. So we use that equation to simplify things for us. So it's EPF minus EPI. So we've got this equation, and then this is the work done by the frictional force. So the work done by Fk is equals to half into 1.8 into the Vf is 4 squared minus the Vi was 0.95. You square that plus into EPF is 0 minus EPI, which is 26.46. So this is actually the simplest way of finding the work done by friction. So it's equal to, you just punch that whole thing on the calculator, you get your answer, and you are good to go. So it's 1.8 into 4 squared, which is 16, minus 0.95 squared, and then plus into 0 minus 26.46, and it gives us negative 12.87 joules. So obviously the energy is taken from the system in an irreversible manner, since it's being taken by frictional force. And then we go to 5.6. Surface BC in the diagram above is frictionless. There's no friction when it moves from here all the way to there. So that means we've got no friction. If we've got no friction, we also do not have any applied force. We also do not have any FG parallel. So that means it's moving with the energy that it had when it reached B, and then eventually it continues with that. So they say, what is the value of the net work done on the objects as it slides from B to point C? So obviously the work net is going to be 0, because there are no forces that are acting during that motion. So that is that.